Hi, my name is Andrew Dichenko. I'm a PhD student at MIT, and today I'll be presenting my paper on C2KD, Cross-Lingual Cross-Modal Knowledge Distillation for Multilingual Text Video Retrieval. This is joint work with the following authors. Text video retrieval is a task of retrieving the most relevant videos to text queries. This is becoming an important task with all the videos uploaded to the internet. In text video retrieval, videos are ranked according to the similarity to text queries. Most methods are trained and evaluated with English text, while we focus on improving the performance for more languages. As an example, suppose we have the query, pour the marinade onto the chicken and mix. We'd like to see videos which are relevant to this text query. Using our model, the top 5 most similar videos to this text query are shown, which are all related to the text. Text video retrieval models are similar to text image retrieval models, such as CLIP from OpenAI. CLIP uses a text encoder and an image encoder to encode a batch of text and images. Then the similarity score between text queries and images are computed with the cross-modal similarity matrix. The model is trained with the cross-entropy loss, also called the noise contrastive estimation loss, where it tries to match the correct image to a given text query. The cross-entropy loss is applied a second time, so that the correct text query is matched to a given image. We can make a video encoder from CLIP's pre-trained image encoder by treating the video as a set of images, extracting features from each frame, and passing them through a transformer to get an output embedding. Now we can develop a text video model which is similar to CLIP. We use a query encoder like a pre-trained BERT and use it to extract representations of English queries. Then we can use our CLIP video encoder to get an embedding from the video. Given a batch of text queries and video inputs, we can compute the text-video similarity matrix. Finally, the cross-entropy loss is applied between the distribution of text-video scores and the one-hot distribution of the correct match. This encourages the model to have higher similarity scores for matching text-video samples. In this work, we instead address the problem of multilingual text-video retrieval. Prior work has handled this problem by using a multilingual query encoder, such as multilingual BERT. This method assumes a dataset where each video clip has multiple captions, which are all translations of each other. The translations can be human translated or machine translated. For each language, the text is passed through the same text encoder, while the video representation is the same for all languages. For each language, we can compute the text-video similarity matrix between the captions and the video. We can then apply the cross-entropy loss to each similarity matrix. All of the losses are added to each other in a multitask fashion to train the model. We observed that for these multilingual models, the retrieval performance for other languages was worse than English. This implies that the English text video scores are the most accurate. We propose to use the English text video model as a teacher for a multilingual text video student. We call our method C2KD since it distills both cross-lingual and cross-modal knowledge. We start by training an English text video model, as described earlier. We train multiple English text video teachers, which have the same video encoder but different text encoders. The motivation is that different text encoders can provide complementary information. All models output a text video similarity matrix. We need a way to combine the text video similarity matrices, so we apply a pooler, such as max, min, or mean pool to get a single text video matrix. Finally, in our C2KD framework, we start by training a multilingual student with the cross-entropy loss as described earlier. We then introduce the teacher models, which only use English text as input. We apply the cross-entropy loss between the multilingual student text video similarity scores and the teacher text video similarity scores. We call this the C2KD loss. The final loss is a combination of the original loss and our new C2KD loss. The difference between the original NCE loss and the C2KD loss is the target distribution. The former uses a one-hot distribution, while C2KD uses the distribution from the teachers, which is smoother. This gives the model some leeway and can be helpful when there are several good video matches for a text query. It distills cross-modal knowledge, which is consistent with the text video retrieval task. For the experiments, we use two existing video datasets, Multi-MSR VTT and VATEC. Multi-MSR VTT has general videos such as sports and cars. There are 10,000 video clips, and the English captions were machine translated to 8 other languages. For VATEC, it has videos from an action recognition dataset, their 29,000 video clips, and their English and Chinese captions. We also introduced the multi-UCOOK2 dataset. We use machine translation to translate the English captions from the UCOOK2 dataset into 8 other languages. There are 13,000 cooking video clips. Here are some examples from the dataset. The translations have some mistakes since they are from machine translation, but they are fairly accurate. For the student text model, we used the LabC multilingual model. We also considered other models. For the video model, we used clip image features at 1 frame per second and a 2-layer transformer. For the results, we report the standard recall at K metric, where higher is better. Recall at 1 means the correct match is the first result. We first conducted an ablation to find the best multilingual text encoder. We found that LabC gave the best results compared to others, so we used it as the text encoder for our multilingual student. We also conducted an ablation on the number of teachers. Using one teacher, there was a clear distinction between the effectiveness of different models. The performance was better with 2 teachers than with 1. The best performance was with 3 teachers. We also found it essential to distill the text-video distribution instead of distilling individual text-video scores from the teachers. The cross-entropy loss between the student and teacher text-video scores worked the best. Regressing individual text-video scores, such as with an L1 loss, worked worse. For the results, on multi-MSR VTT, we found that C2KD improved the performance across languages. The average recall 1 improved by 16.2% relative. The largest improvement was on Spanish, with an 18.6% relative increase. On our new multi-UCOOK2 dataset, we found similar results. The average recall 1 improved by 6.6% relative. The largest improvement was on Japanese, with an 11.9% relative increase. For more results, please see our paper. Qualitative results are shown here, both with and without C2KD for queries in English and Chinese. Using our method, the model can accurately retrieve video clips relevant to the text query. Our model can handle text queries in other languages, such as Russian and Japanese. For future work, more multilingual text should be acquired. Machine translation can now be applied to over 100 languages, and other strategies like text augmentation and paraphrasing strategies could be used. We are planning to release the code and the data and invite the community to try them out. Thank you for your attention. Feel free to contact me with any questions.